Okay, so today what we're going to work on are slant asymptotes. So I want you to put me on pause, do the try this, which is to sketch the graph of the rational function using the guidelines. So put me on pause and then come back and check your answer. Okay, so the first thing I want to do is find the y-intercept. So remember that's when x is equal to 0. So that would be 0, 5. Next we want to find, just going to make it a little bit bigger, the x-intercept. That's when y is equal to 0. So that comes out to be negative 5/2, comma 0. Or negative 2.5, comma 0. The next thing is we want, number 3, we want our vertical asymptotes. That's when the denominator is equal to 0. So that's 1 plus x equals 0, so x equals negative 1. And then I would want when my horizontal asymptotes. Okay, so that's the 2x over x. So I have, these are the same. So when they have the same exponent, right, so that means n is equal to m, so that means my horizontal asymptote would be the coefficients, the ratio of the coefficients, so that's y is equal to 2. And then next I would want to make a table of values to get some other points to plot. Okay, so I'm going to use negative 3, negative 2.5, negative 2, not negative 1 because negative 1 is an asymptote, 0 which is 5, 1 is 3.5, 2 is 3, and 3 is 2.75, and I have these over here, so this is 0.5, 0, negative 1 here. Okay, so now let's see, let's start graphing here. So I have some asymptotes. So my asymptotes, let's start with that, is at y equals 2. Okay, there's one asymptote. And I have x equals negative 1. Okay, and now let's get, let's plot some of our points. So I have y-intercept is 0, 5. 0, 5 is my y-intercept. I have an x-intercept at negative 2.5, comma 0. Okay, so at negative 3, I'm at a half. At negative 2.5, I'm at 0. So you can see I'm starting to go down, I'm going down towards my asymptote. And at negative 2, it's negative 1. Alright, so it looks like my graph is going like this. Okay, so let's continue. So I have 0, 5 there. I already have that. 1 is 3.5. So it looks like it's going down to my asymptote. And I have 2 is 3. And 3 is 2.75. So it's definitely getting closer to my asymptote. So it's going to look like this. Okay, so now let's talk about slant asymptotes. So let me just move everything up. Okay, so we have here, you have a slant asymptote if the degree of the numerator is exactly 1 more than the degree in the denominator, then the function has a slant asymptote. If there is a slant asymptote, use long division to find the equation of the asymptote. The dividend is the numerator and the divisor is the denominator. The slant asymptote is the quotient. It's the quotient without the remainder though. Okay, so we have here, find the slant asymptote. So first of all, notice that my my degrees, right? I have an x squared and an x. That is, my x squared is one more than my x. So that means there's going to be a slant asymptote. So I'm going to take the denominator, x minus 1, and divide it into the numerator, x squared minus x minus 2. Okay, so I get x here. So I multiply down, I get negative x squared. Subtract. So that cancels, and this also cancels, so I have minus 2. Bring it down. So I get 0, so plus 0, which is 0. So my remainder is negative 2. So my quotient and my slant asymptote, so my slant asymptote is y equals x. That's my quotient, is x. All right, so let's try the next one. So I have x squared and x, so my numerator degree is one more than my denominator degree, so that's x plus 2 divided into x squared plus x minus 1. Okay, so I have x, I multiply down, I get 2x, positive 2x, and x squared. Subtract, I get negative x, bring down the minus 1. So now I get minus 1 up here, multiply down, I get negative 2, negative x. Subtract, and I get positive 1. So my slant asymptote is y equals x minus 1. Okay, so now we want to graph with these. So let's flip it over. Okay, so now let's graph with our vertical asymptotes, horizontal asymptotes, and slant asymptotes. Okay, so just like everything before, we want to find our y-intercept. So I'm going to go through that quickly. We should be pretty good at that. Our y-intercept is 0, 2. Our x-intercept is 2, 0, and negative 1, 0. And now we want our vertical asymptote. So that's x is equal to positive 1. And then we want our horizontal asymptote. Okay, so that's, so we have an x squared over x. So my numerator, the exponent is bigger than the denominator. So that means there does not exist a horizontal asymptote. And now I want my slant asymptote. So this graph here, this guy here is the one from before. So we already did that. That was number 1 from before. So my slant asymptote is all right, so my slant asymptote is y is equal to x. And now I want to find some points to plot. So I have an x and a y. So I'm going to use negative 2, negative 1, 0, 0.5, 1.5, and 3. All right, so at negative 2 I have negative 1.33. Negative 1 is 0, 0 is 2, 0.5 is 4.5. 1.5 is negative 2.5, and 3 is 2. Okay, so let's put in our slant asymptote. That's the one that's on the diagonal. Okay, so there is your y is equal to x. We have a vertical asymptote at x equals 1. That's going down this way. Okay, so now let's start plotting some points. So I have here my y-intercept is 0, 2. And I have x-intercept is 2, 0. And negative 1, 0. All right, so now let's start plotting the other points here. I have negative 2 is negative 1.33. So it's really close to that intercept, that asymptote. I have negative 1, 0, which is I have 0, 2, and then I have 0.5, and then 4.5. So it's like up here. So my graph is going to look like this. Okay, and then on the other side, I have 1.5, negative 2.5, so that's down here. And then I have 3 and then 2, which is up here. So that graph is going to look like this. Okay, so let's try another one. Okay, so we're going to start with the y-intercept. So number 1, y-intercept is going to be 0, negative 1/3. And I have x-intercepts. There's actually no x-intercepts for this, so if you plug it in, you would see. If you solve it, you'll see that it's actually imaginary, so there's none here. It does not exist. The next thing I would want is my vertical asymptote, which is x equals 3. Okay, the next thing I would want is my horizontal asymptote. So I have an x squared over an x. So that does not exist when the numerator is bigger than the denominator, the exponent. So it does not exist. And I want my slant asymptote. So this slant asymptote I'm going to have to figure out over here on the side. So I have x minus 3 divided into x squared minus x plus 1. So I get x. That's negative 3x, x squared. Subtract. So I get 2x plus 1. So this is plus 2. Multiply down, I get negative 6. And 2x, subtract, and I get 7 as a remainder. So this is my slant asymptote. So this is 5. Slant asymptote is y is equal to x plus 2. And let me just get rid of that. So now I need to get some points so that I can plot them. So I have x, y. So I'm going to use the points negative 2, which is negative 1.4. Negative 1, which is negative 0.75. 0 is negative 0.33. 1 is negative 0.5. 2 is negative 3. 3, there's the asymptote, so I have 4 is 13. We're going to have to go, keep going here. 5 is 10.5. 6 is 10.33. 7 is 10.75, and 8 is 11.4. Okay, so now let's graph this. So let's start with our asymptotes. So our asymptotes are at x equals 3. And y equals x plus 2. Okay, so now let's start plotting our points. Alright, so I have a y-intercept of 0 and negative 0.3 repeating, so it's like right in there, a little bit below 0, 0. I have no x-intercepts, so now let's start plotting our other points. I have negative 2, negative 1.4. And then I have negative 1 is negative 0.75. And then I have 0, I have that already. 1 is negative 0.5. So now it's starting to come back down again. 2 is negative 3. So it's like this. So your graph is going to look like this. Okay, so now let's check the other side over here. I have 4 is 13, so that's all the way up here. 5 is 10.5. 6 is 10.33, so it's a little bit closer. And 7, now it's going back up. 7 is 10.75, and 8 is 11.4, so it's looking like, let me just pull it down a tiny bit. So it looks like that. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.